The angular momentum of the system relative to any point P is calculated like that of a system of particles, except that we're gonna do a continuous integral instead of a discrete sum. So the angular momentum of a system to any point P is Hp is equal to the position vector from the point P to the particle, that's r minus rp, crossed with v dm, the velocity of the individual particle times its mass. So here when I'm talking about particle, what I mean is the differential mass. And that's integrating over the body. If you want to calculate the angular momentum about the center of mass, I can write that as hc is the integral over the body of r minus rc cross v dm. And about any point O, or about the origin O, I can write HO is equal to the same integral of r minus ro this time cross v dm. And the origin, well, is the zero vector. The position vector, the origin is the zero vector. So that's the simplified expression for HO. I can also relate the angular momentum HP and HC through this equation. Let us show this. I will start with HP. And then what I'm gonna do is I'm gonna introduce inside a plus RC minus RC. So maintain the equality. And then we can distribute the multiplication over the sum and split the integral into two to get the integral of r minus rc cos v dm plus the integral of rc minus rp cross v dm over the body. And this, the first integral, is just hc. The second integral is a little bit interesting. rc minus rp does not depend on the differential mass dm, so I can just take that outside the integral with the cross product, and I'm crossing that with the integral of v dm, which is none other than our friend over here, the mass of the system times the center of mass, or the linear momentum of the system. The total mass times the velocity of the center of mass. So hence I've showed that HP is HC plus the position vector from P to C crossed with G. For the special case when point O, when point P is the origin O, if P is taken to be the origin O, then I can write HO, replacing P by O. HO is equal to HC plus RO minus RC minus RO crossed with G, and RO is just 0. So that's HO is equal to HC plus RC crossed with G. Very well.